Welcome back to Programming with Qt Widgets. This is the fourth module, and in this module, we'll talk about dialogs and main windows. Wait a minute, Jesper. You told us far, far away, time-wise that is, that all I needed to get a top level was to provide a null pointer for the parent. So why do I need dialogs and main windows? Well, for that, we need to go back slightly in time. We need to go back to 1723. Well, Qt didn't exist back then, but back then there was a play called Erasmus Montanus, a very famous Danish play. If you don't know it, well, let me give you a short piece of that. It goes like this. A stone can't fly, mom can't fly, therefore mom is a stone. And it's exactly the same mistake that you made. When you came to the conclusion, we don't need anything specific. All we need is to provide a null pointer. Well, indeed, you can get a top level with a null pointer, but using QDialog and using Q main window, you get additional facilities. And let's look at QDialog to start with. The base class of dialogs are, no surprise here, so no drum rolls, QDialog. And QDialog can be run either as a modal dialog or a modal-less dialog. And then modal dialog is a dialog that comes up and it blocks the user interface saying, hey, do not operate the rest of the application behind me until you have addressed me. A good example of a modal dialog is a login dialog. It would be rather annoying if it was possible to just take the login dialog in this short here and just move it out of the way and then continue using the application. So therefore, that blocks the user interface for the rest of the application. You can find lots of modal dialogs, and some of those that even ought to have been modeless. An example of a modeless or modal-less, I guess it's called, dialog is a search dialog. It allows you to operate a bit on the dialog, a bit on the main window. You can search, or search and replace, and you find something in your application, say, hey, that should not have been written like that. Let me just fix it right away and then continue your search and replace. Had it been a modal dialog, you would be searching and replacing, and all of a sudden you say, oh no, on page 225 there is a terrible error that I need to fix. All you can do is get a pen and a paper and write down a note to yourself to go fix it later, had it been a modal dialog. You bring up a modal dialog by calling exec. You bring up a modeless dialog by calling show. And let me just get my pen and paper out again, because it helps in remembering what's going on here. And sorry for looking at my baldness here in my hair while I'm drawing. What I like to draw is a table for you, because I was slightly lying to you when I said the part about exec and show is how you get a modal versus non-modal. And let me just show you this table here. Exec and show. As I said, a modal dialog is usually brought up with exec, and that is our login dialog. A non-modal dialog is brought up with show, and the show non-modal combination, that was our search dialog. Okay, so far so good. But there is one situation, namely a modal dialog that you bring up using show. And if you are sitting there saying, wait a minute, Jesper, you didn't tell us what exec does. Well, what exec does, we need to understand that. It blocks on the line where you called exec. And I'll show you that with a bit of drawing in just a second. But it blocks on the line while show just continues on. And now you ask yourself, when would I want to call show instead of exec on a modal dialog? And if you can't find the answer to that, don't be shy, or don't feel bad. That's what I'm trying to say, because I think it was an oversight back in the Qt 2 days, because back then, and there's a link here, we had Q semi-modal dialog. And that, I can only think of one reason why you want a Q semi-modal dialog. That was progress dialog. Imagine a progress dialog coming up saying, okay, I'm formatting your hard disk. Of course, it's blocking the user interface, so you can't stop the formatting halfway through. And then it would be sitting there waiting until you press OK at the end, or when the progress was done, so it can continue on and actually do the formatting. That wouldn't work. You would want to continue on right away. So your Q progress dialog is one that is modal and shown. And the way that you get a modal shown dialog is simply to call set modal on the dialog just before you show it. And now you ask yourself, but Jesper, there is a fourth quadrant in your... And let me just... No! Actually, I think it was a Qt 4 days. It was possible. And I had an example that I showed in classes back then, which got us into some terrible re-entrance problems. Let me also draw that to you just in a second. First, let's see what exec looks like. To understand exec, we need to go back to the very beginning. Not when Earth was created with Big Bang or people getting ribs torn out of their... No, back to the beginning of our application. Where did it start? Well, it started with this little fellow that you already seen me draw. It says while true. And in this while true loop, which we did discuss already, is not a while true loop, but conceptually it's a while true loop. We called out here for something called process events. So running around the while true loop, process events, the X server, for example, asked the system underneath, did anything happen? And the system underneath said, well, the X server said to the Qt application, no. Qt application asking again, did anything happen? And at this point, the user pressed the mouse button. So a mouse press event came in. That was possibly on a Q push button. So a clicked signal got fired, and that went into some slot somewhere down here. So down here, you have some code. That's what a text file looked like. And in that line of code, you wrote exec, well, parenthesis open, parenthesis closed. What the exec code does, if you go and look at the source code of exec, it does exactly this little fellow here. And yes, you did recognize it to be yet another event loop. And now this event loop called process events here, and the process event will take care of asking the X server again, did anything happen? Did anything happen? Oh, a repaint. Well, I'll repaint the user interface. Oh, the user clicked on a checkbox. I'll do that until eventually the user presses the OK or the close or the cancel or presses the cross or whatever brings this modal dialog to an end. And at that point, the exec will return and obviously go through all of these ... which was the mouse press event that has been sitting there waiting for minutes or hours or days or however long the modal dialog was up. And the event will return back to our event loop. The event loop will run around again, and the recursive event loop will no longer exist. And now with this new knowledge, we understand why we cannot show a modal dialog. Let me show you. So we have a user interface. It looks something like this. And there is a big button in here that says go. Whenever I press that go button, it will exec a dialog. So we have the event loop we've seen here, goes out to process event. Down here is my exec call. And I bring that up. And that, of course, starts a new event loop. I press the button again. My process event goes out. I start. I hit the exec once again, and it starts a new event loop. And at this time, I actually do have two dialogs up. I have one dialog representing the first, another one representing a second, and they likely look whatever the same here. And now I press I better have a close button, so there's a close button here on each of those two. I press the close button of the second dialog, and that one, all it'll call is a static method on Q application saying Q application, or on Q event loop, it'll call Q event loop close, or Q event loop quit, I think it's called. What it will do is that it will then stop this event loop here, which will kill this dialog, and I'm back in the original setup. But let me just undo here now a bit. I hope I can do that. Too much undo. There's my button again. Now, if I press this button up here, I press that one, what will happen? Well, Q event loop quit. It will quit this event loop. Quitting the event loop will get me back up to this. Well, the event loop will go up to the exec line, and likely short after it will call delete on the dialog, and I'm back into this event loop. But that was not the dialog that I closed. This is not a problem anymore. So I just wasted a few minutes of your time, but hopefully give you a bit of insight into, again, how the event loops in Qt works. Developing software with Qt is easy. You write it once, you deploy it everywhere. So the ad says at least. But sometimes there are tiny differences between different platforms. But fortunately, in QDialog, we have a vast amount of experience in that. We have people that can help you both on Windows and on Linux, and of course, Macintosh and embedded devices. So reach out to us if you have any of these kind of problems. To bring up a modal dialog, we just call exec, as you can see in the code here. I create an instance of my dialog, and usually I operate with subclasses of QDialog rather than QDialog directly. I specify this as the parent here, and I'll get back to that shortly why that is important. And then I call dialog.exec and test on the return value whether it's an acceptable, or whether the dialog was accepted, meaning okayed. Now, I'll of course block here, and down in this code, that's where I'll go dialog.login and dialog.password or whatever to get the values out of the dialog. Super convenient. I have the dialog pointer right there. I know at line 4 and forward that it was accepted. Let me be honest with you. This is what my code in my application looks like. But there is a framework called KDE, a huge desktop application for Linux, or desktop framework for Linux written in Qt. And from there, they had a problem, namely that you could send to any KDE application debug messages and tell the dialogs to actually close. And therefore, this code came around slightly safer. So what you see here is I have an instance of a Q pointer around my dialog. And Q pointer is not just a old version of a std unique pointer. Q pointer is actually a bit more, well, it's a different at least. What Q pointer does is that it connects to the one and only signal that Q object has, namely destroyed. And my dialog here must be a subclass of Q object. Well, it's a subclass of QDialog, so obviously it is, but for the Q pointer to work, it must be a subclass of Q object. What it does then is that when that Q object is being destroyed, it will internally set the pointer that it has to a no pointer. And that way we can go down here and test, is the dialog still available? So you bring up the dialog, you wait for the dialog to be accepted, but the dialog might actually be accepted by a debug message or a timer or something else that is acting in that recursive event loop that the exec brought up. And that might actually have caused the dialog to be deleted already. And well, KDE application, a lot of them crashed whenever their dialogs was closed behind such a line here. But we test whether dialog is actually alive still. And if it is, then I will use it. Let's go back and look at this here in line 1. What this is, as always, a parent pointer. And just with the mom and stone and whatnot, just because I specify parent do not mean that I am not top level. This is just to figure out where should the dialog be placed. Usually, well, it could at least be placed inside of the window that this is specifying. And furthermore, whenever I close the dialog, this is what will get the focus back. Of course, many of these things are window manager specific. There is another issue with pointers of parents in the context of modal dialog. Imagine this setup here. I am a modal dialog. I stand here and block the user interface, but must be around here. There is a button saying details, and when I click that details button, what will happen is another dialog will come up. And in that dialog, I could get some details. I can modify some details about my dialog. And that, of course, should not be blocked, because how would I then modify those details? The rest of the equation, blocked. That dialog, not blocked. And the way that Qt figures out whether you can interact with a widget or not is to go from that widget and go up, 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 up in the parent-child relationship until it gets to the dialog that is modal. Okay, so it's a child, therefore it should not be blocked. Bringing up a modeless dialog is as easy as it bringing up a show dialog. All I need to do is to call show on the instance that I created. However, I cannot read the values out of the dialog on the line after show, because show will not create a secondary event loop. Therefore, it will simply not block the user interface. It will just continue on right away. So what I need to do is to bring up the dialog by calling show, and then I need to connect to some signal that indicates to me that the dialog is actually done or has been closed or okayed. And that's what you can see in this code here. So first of all, in my header file, I'll create an instance of this dialog here. And this is just a best practice to make sure that I do not need to create the dialog in my constructor. If I did, it would just be wasted CPU in case that the user never brought up the find dialog, but that I do not recreate it every single time I get into the find setup again. So what I have here, I create my pointer. Could have been a std unique pointer in case that there was no issue with the dialog being closed, or it could be did I almost say a raw pointer? I of course didn't mean that. I did not say. It should be at least a std unique pointer then. And then in my find, that's the slot connected to my find button. In here, I'll test whether it has ever been created, and if not, I'll create my dialog. And here's my connection of, well, whenever something, well, this was the find next. So that was some operation from in there, but it could also be that I wanted to connect to a close in case it was a configuration button where a configuration dialog doing a lot of configuration, and then in the end saying, okay, then I would connect to the closed signal saying, okay, now I can go and set up my application based on what it was. These three lines, you would usually see them together in that setup. First, show, in case it never been shown. It would have been closed. Show, in case it never been shown. Raise, meaning just imagine that it was already shown on the screen, but it was underneath other windows. Then raise will bring it to the top. And finally, activate window, give keyboard focus to that window. We've seen how to bring up a dialog using show or exec, but how do I create my dialog? Well, I could, in the slot connected from the find button in the previous example, just create my dialog right away. So auto dialog equal to new QDialog, populated and so on. but that would be kind of code bloat inside of the surrounding class that had that find button. Much better example, and the example that we do from Qt Designer, for example, is to create a new class for each of our dialogs. And I know that I've told you many times, do not create your layouts by hand, do them from within Qt Designer, and that still applies. What I'm showing you here is really just for you to better understand what does Qt Designer do and how would you do it in case that you had a very corner case. So what you do is inherit from QDialog. You create your layout and your widgets in the constructor, and you use this QDialog button box, which Qt Designer also do, which is for the OK and cancel, and its sole purpose is to get the OK and cancel in the correct order depending on the platform. And then you connect the accept and reject signals to your accept and reject slots in your dialog. See, it's important that you do not just invent new slots. You could have connected this reject to my reject, but then one crucial thing would not work, namely that if you press the cross on your dialog, that will call, or that will make the QDialog button box not emit the reject, because QDialog button box is just these two buttons in a layout wrapped in a Qt widget. So that would not emit that. But the reject slot or the reject virtual method of the dialog would still be called. So you need to override the reject to make sure that if there was something that you needed to undo in case the user did not accept the dialog, that would actually be undone. That was it for this very first episode of the module here on top levels. We saw QDialog, and just as with the widgets, there is a bunch of widgets that already do exist, Q checkbox, Q whatever. There also is a number of dialogs that already exist that you do not need to invent yourself. We'll see those in the next episode. Until then, have a great time.